Okay, guys, we've got 3 lessons to finish up this unit. So we just had the quiz, maybe a mixture of good news and bad news, but that quiz was over about 70% of the material. We're going to cover the other 30%, and then there's a test. So this material comes back next Friday. Okay, so a week from now, you'll have a test, and it's going to look a lot like this with the 3 different pieces of information that we'll put in the next 3 lessons. Now, what we need to be really cognizant of in this unit, and this is where we're ultimately going in this unit. So the big thing is I want to be able to graph polynomials, okay? So I want a solid skill for graphing polynomials and reading information from graphs of polynomials, okay? I can't just start out with that. So we had to do a lot of things, okay? So in order to do this, we needed to figure out the degree and the leading coefficient. Those were 2 pieces of information we did on day 1 because they help us know what? What do these 2 things tell us? The what? Yeah, but how do I use the intelligence I get from that information? What does it tell me? The degree and the leading coefficient tell me what? Yeah, the end behavior, okay? So I had to use those things to get the end behavior, okay? And then some of the other skills that I needed along the way. I needed to know how to factor. We also talked about synthetic division, okay? Because that would help me take a polynomial and get it in factored form, because once it's in factored form, what is it easy to diagnose once you have it in factored form? You can tell me the what? When it's factored, you can look at it and tell me what? The what? The x-intercepts, or the roots, okay? So that's how I get the roots. Another word for that is the x-intercept, okay? Other things that I needed along the way to graph this polynomial, I needed to figure out how to find the y-intercept. And then other things we talked about, you know, roots and multiplicity. So we covered quite a bit in this unit. We started down here because if my goal was to get you to graphing polynomials, these were all building blocks that I needed along the way to get there. Now there's some other things we did along the way, things we've done earlier in the unit. You know, when is something increasing or decreasing? That's something we've done before. We talked about extrema, which is just a fancy word for max and min. Okay. And then we talked about how to tell when a function, the intervals where, you know, f of x is greater than 0, f of x is less than 0. Okay, so there's a lot of stuff in this unit, and it's pulling from a lot of stuff we did. So factoring, we did that back in August, you know. Intervals where it's greater than less than 0. We did that back in August, September. So a lot of stuff has been pulling together. So what I will say is I was a little bit surprised. I'm not calling any names, and it happened in both my classes. On the day of the test, you know, I had people that had questions about this, finding the degree and the leading coefficient, okay? So if you're having a struggle with this was a very basic building block. I'm not saying it's easy, but this was information that was key to going further upstream here, okay? So you got to make sure that you're solid. If you need to go back and take a look at that, go ahead and do it. But this unit, more than any other we've done, you can look at the number of building blocks. There are 5 or 6 or 7 different things that all come together to help you graph these polynomials, okay? So you got to keep those there because, like I said, we're not setting them aside. We're just marching on a little bit, and this material will come back a week from now. So you got to be really solid in factoring, because if you factor a polynomial, when you see x minus 3 as a factor, what's the root or the x-intercept? Come on, guys. If x minus 3 is a factor, 3. Yeah, the point 30 is the root or the solution. So getting it in factored form is really key. But we got to make sure that we can factor. So if we look at this, these are things we've done along the way. Greatest common factor. How do I factor this? What's the greatest common factor? Yeah, so the greatest common factor numerically is a 2, and then an x. When I factor that out, what am I left with? Yeah, x minus 3, okay? So sometimes in solving these polynomials, you may see greatest common factor coming back. Difference of two squares. What is this guy? Yeah, x minus 2, x plus 2. Quadratic trinomials. This one occurs probably the most frequently in this unit, and there were people that struggled a little bit with this in the previous test. So x squared minus x minus 2. In this case, I need two numbers that do what? Yeah, multiply to negative 2, add to negative 1. What numbers will do that? Yeah, negative 2 and positive 1. What do I do with these numbers? Right, so since this starts with an x squared and not a 2x squared or 3x squared, I go straight to my answer here. My answer is x minus 2, x plus 1. And I'm done. That's the factorization of that one. Now, it's a little bit different when the number in front of the x squared is not a 1. Now I look for two numbers that multiply to give me what? Yeah, multiply to negative 24 and add to negative 5. What numbers would do that? So if you have trouble with this, just remember it's 1 and 24, 2 and 12, 3 and 8, 4 and 6. What's the only way those numbers combine to give you a 5? 8 and 3. And so to make it a negative 5, which one's negative? The 8. Okay, now what do I do with these numbers? I have to put them back and then factor it by what? Grouping. So I have to rewrite this as 2x squared plus 3x minus 8x minus 12. To factor by grouping, what do the first two terms have in common? X. So this is x times what? 2x plus 3. Whatever the sign is that I see next, the minus sign, copy that down. What do the 8 and the 12 have in common? Yeah, so 4. What do you multiply negative 4 by to get a negative 8x? Yeah, 2x. What do you multiply negative 4 by to get a negative 12? Positive 3. So what is this factorization? X minus 4, 2x plus 3. Okay, you needed to know how to do this method on this previous quiz. Some people got to this part and they just sort of stopped, but you have to be able to factor that completely. And by factoring completely, it's factored in terms of terms that are multiplied with each other. And then we just did factor by grouping, but factor by grouping is the only method you have for 4 things. You look at the first 2 things, what is in common here? X squared, and you're left with 2x plus 1. Copy down that minus sign, and this is also what, 2x plus 1. So this is x squared minus 1 times 2x plus 1. Is that completely factored? No, what can factor now? Yeah, x minus 1, x plus 1, 2x plus 1. Okay, so this is just a real high level of the different things we did factoring wise so far in the class. What do these things all have in common? What does it say there in bold? They will all be on the final exam. Okay, so that's one thing they have in common. They're all specific cases of when we use these methods. You know, when can I use difference of squares? You got 2 things with what in between them? A minus sign, and they're both perfect squares. Okay. Common factor, when you look at all the terms and they share something in common. If it's got 4 terms, the only method we know is grouping. And then the other thing we deal with is the quadratics, when it starts with an x squared or when it starts with an ax squared. So that's pretty much it. Okay. Now, what we want to do, we need to return to our polynomials. On the previous test, if I ask you to factor that, I would say factor that, and I would say given what? What would I give you? Yeah, I would give you one of the factors or one of the roots, okay? So, doesn't it feel like that's cheating when I give you that information? Does or does not feel like it's cheating? Wouldn't you rather be able to do it without me giving you that information? This is why I'm trying to lead the witness. Well, we're going to do it anyway. so what I want you to be able to do now is I want you to be able to factor that, and I'm not going to tell you that x plus 2 is a root, okay? So you're going to have to use synthetic division, but we're going to sort of guide you to how do you make good guesses toward that, okay? So let's look at a polynomial like this. Which term is my constant? 15, okay? What is the leading coefficient here? 1, okay? The leading coefficient is 1, okay? What are all the factors of the constant term? So the constant term is 15. What are the factors of 15? It's 1 times 15. It's not 2. It's 3 times 5 and 15, okay? Those are all the factors of the constant term. Now, what are the factors of the leading coefficient? This one's easy. 1. The leading coefficient is 1. The factors of the leading coefficient are 1. So the rational roots theorem tells me that if this polynomial can be factored and it has rational roots, they're going to be of the form plus or minus p over q, where p are the factors of the constant term, q are the factors of the leading coefficient. So it tells me that if I want to factor this guy, and I didn't give you a factor to start with, if it has factors, it's going to be plus or minus the factors of 15 divided by the factors of 1. So the factors of the constant divided by the factors of the leading coefficient. So all you have to do is say, if this thing factors, the roots are going to be plus or minus the factors of this number divided by the factors of that leading coefficient. So let's figure out what that list is. So all I need are plus or minus, so it's going to be plus or minus the factors of 15 divided by the factors of 1. So this is plus or minus, we just talked about, the factors of 15 are what? 1, 3, 5, and 15. The factors of 1 are 1. Okay? So the list of possible factors are, so take every number on this list and divide it by this number. This one's pretty easy. What is 1 divided by 1? 1. 3 divided by 1. 5 divided by 1. And 15 divided by 1. So those are the only possible rational solutions that there are. Okay? So my goal now is to start looking at these guys and see if I can get one of them to work. Okay? So how many possible are there? There's what? 1, 2, 3, 4. I got plus and minus. There are 8 possible choices. Okay? So at worst case, I've got to try synthetic division how many times? 8 times to get one that works. But this is going to have 3 solutions, so I'm probably not going to have to go that. So my goal is, if you would just line these things up smallest to largest, my goal is not to make you go through a big long list and like, yeah, the 8th one works. That's not my goal. So you should try plus 1, minus 1, plus 3, minus 3. Somewhere pretty quick you're going to get one that works. Question? Right. What happens, so this is a 3rd degree. Remember on the last test I would give you one root or one factor, then you would get it into quadratic and you would factor it. You would no longer be guessing. Okay? So if I can get one of these to work, that takes it down to a quadratic that I know how to factor. So let's just try this list, okay? Yes, because it starts out with a cubic. If I can find one that works, that gets me to a quadratic. I can factor a quadratic. I don't have to do the guesswork anymore. You can't stop. You have to factor the quadratic. Okay, so let's look at this. My goal is just to start with that list. Let's just try the number 1. Okay, so 1, and I've got 1 minus 3 minus 13, 15. So I'm just going to try this and see what happens. 1 times 1 is 1. That's negative 2. 1 times negative 2. That's negative 15. 1 times negative 15. And you are in luck because what happened? Yeah, this one works. Okay, so what did we just figure out? We just found out that 1 was a what? No. X equal 1 is a solution or a root. What's the factor? X minus 1 is the factor. Okay? You have to be very comfortable going back and forth between what's the factor and what's the root or solution or intercept. So I can write this polynomial now as what? What's the factor? X minus 1. So this is x minus 1 times, how do I read that bottom row? X squared minus 12x, 2x, sorry. Minus 2x, and then what? Minus 15, okay? So now I've got it down to where it's a quadratic. What do I do with this quadratic? Yeah, so now I need to find two numbers that do what? Yeah, multiply to negative 15 and add to negative 2. So what numbers do that? It looks like it's going to be, what, a 3 and a negative 5? So what do I do with these numbers? Yeah, x plus 3, x minus 5. So that is the complete factorization, okay, of that polynomial. So I was able to factor this without giving you any factors to start off with. So what you had to do is you had to build a list of all the possible roots, okay? Now, if you were to try 4, it's not going to work. 7 is not going to work. So this gives you a smaller target list of, if it factors, it has to be one of those numbers, okay? Now, it's possible that 1 wouldn't work, negative 1 wouldn't work, and then you maybe would have gotten another one that would have worked, okay? What are all the ones that would have worked here? Yeah, negative 3, positive 5, and 1. All of those are on this list, okay? So your goal is, I got 1 to work. You could have started with negative 3. It would have worked. You would have gotten to the same answer, okay? So, listing. I think this was the one that we just did. It was just, I just did it all there together, okay? So the steps were, get it down to a quadratic and factor that, and then we wrote our complete factorization. So let's get another example of using possible rational roots. Some that are a little bit harder, maybe we won't solve those. So the possible rational roots are going to be plus or minus the factors of what number? Factors of 12 divided by the factors of 3, okay? So this is plus or minus, what are the factors of 12? And I always just start smallest to largest. It's 1 times 12, 2 times 6, 3 times 4, right? So these are all the factors of 12, okay? What are the factors of 3? 1 and 3, okay? So this list is going to be plus or minus. So what are all the numbers? So I have to take every number on the top, divide it by every number on the bottom. What is every number on the top divided by 1? It's just copy down those numbers, right? 1, 2, 3, 4, 6, 12. Now I need to divide each of those numbers by what? 3. What's 1 divided by 3? We'll call that 1/3. 2 divided by 3, that's 2/3. What's 3 divided by 3? 1. That number is already on my list. I don't need to write it down. Okay. What's 4 divided by 3? That's 4/3. What's 6 divided by 3? 2. It's already on my list. What's 12 divided by 3? 4. That's already on my list. Okay. So these are all the possible roots. Okay. Plus or minus the factors of the constant divided by the factors of the leading coefficient. So if my goal were to factor this, I would just start working on this list. Okay, this list is a little bit longer, okay? But like I said, my goal is not to make you go through the 21st time as a charm, okay? You're going to find success in these first few numbers, okay? But you'll have to be confident doing synthetic division. So what about this one? It's plus or minus factors of what? Yeah, so I don't have to write negative because I'm doing this plus or minus. Plus or minus factors of 24 divided by factors of 6. So that's plus or minus. What are all the factors of 24? 1, 2, 3, 4, 6, 12, 24. Yeah, 3, 8. Sorry, I left off 8. Let me get that off. Right after 6, there's also an 8. 8, 12, 24. Okay, this is a big list. Okay, so it's plus or minus all of these these numbers, divided by the factors of what? 6. What are the factors of 6? 1, 2, 3, and 6. This list is going to be a short list or a long list? Long list, okay? So it's just testing whether or not you know how to create this list. So first thing, every number needs to be divided by which number? 1. So that means just copy every number down. 1, 2, 3, 4, 6, 8, 12, 24. Now I'm going to divide every number by what? 2. So 1/2. 2 halves, that's 1. Okay. 3 halves. What's 4 halves? That's 2. It's already on my list. What's 6 halves? That's 3. It's already on my list. 8 halves. That's 4. 12 halves. That's 6. 24 halves. That's 12. Okay, so I don't have to write all of those down. Now let's divide everything by 3. You're going to do 1/3. Looks like you'll get 2/3. 3/3 is what? 1. And then I'm going to have 4/3. 6/3 is which number? 2. 8/3. I need to write that one down. And then what's 12/3? 4. 24/3 is 8. So that's good. Now I need to divide every number by what? 6. So I'm going to have 1/6. Okay. What is 2/6? That's 1/3. It's already on my list. What is 3/6? 1/2. It's already there. 4/6. That's 2/3. I've already got that one. 6/6. 1. 8/6. 8/6 is 4/3. That's already on my list. Okay. 12/6 is 2. That's already on my list. 24/6, 4. It's already on my list. So that's the list. Okay. And again, my goal would not be to make you go through all of these and like all of a sudden 4/3 is the one. Yes, Gilday. No, if you were to write, for example, if 4/6 were to show up here, it'd be okay because 4/6 is 2/3. I'm not going to take off. Yeah, it's fine if you want to do that. I just tend to like the shorter list. But like I said, if you write 3/6 or 4/6, you're not wrong. Okay, so you'll be okay there. So you guys take a break. See if you can do this one. Okay, see if you can figure out this guy. So what may happen on the test is this is pretty ugly, these lists. I may give you a question, give me all the possibles, but don't solve this one, because this one's such a long list, okay? So I may give you ones that are not as ugly when I really want you to go solve it. So let's go do that. So here's our procedure. We need to be able to write down all the possible rational roots. And then we start testing until we find one that works, okay? We keep on doing that until we get to a quadratic. Once we get to a quadratic, what do? Once we get to a quadratic, you know how to factor quadratics. Okay, so that is our goal. So let's just take a look and see if we can get one done here. This guy right here. So what are all the possible rational roots? It's going to be plus or minus the factors of what? Factors of 28 divided by the factors of what? 1. So that's just a fancy way of saying it's the factors of which number? Factors of 28, right? Because the factors of 1 are just 1. So what are the factors of 28? That's 1 times 28, 2 times 14, and, pardon me? Yeah, and then so 2 times 14, 4, 7. So that's my list, okay? Those are all the factors of 28. So I just need to start testing. I always just start with the smallest numbers and go from there. I'll do positive 1, then I'll do negative 1. I'll do positive 2, I'll do negative 2. You know, you can switch things around, but I would encourage you to start with the smallest numbers because I'm the person that makes the test. And I would tend to think, my goal is not have you go through what, 1, 2, 3, 4, 5, 6, 12. My goal is not to have you do this 12 times and the 12th time is the one that works. My goal is somewhere around in here, you're going to find success, okay? So let's start with positive 1. So if I set this up, this is 1 minus 10, 17, 28. So bring the 1 down. 1 times 1 is 1. That's negative 9. This is negative 9. Add those and get what? 8. And 1 times 8. Now once I get to here, to me there's no point of adding those 28 and 8 because it's what? It's not what? Not 0. So I know this is not going to work, okay? So I'm going to move on. So I know that 1 doesn't work. So what am I going to try next? I'm going to try negative 1, okay? So 1, negative 10, 17, 28. Bring the 1 down. 1 times negative 1 is negative 1. Add to get negative 11. Multiply to get 11. Add those to get what? 28. You start to get a good feeling. Negative 1 times 28. Ding, ding, ding. What does this mean? It means what is the solution? Yeah, x equal negative 1 is the solution. What is the factor? X plus 1 is the factor. So this is why we spent time on those early day 1 of synthetic division and talking about what's the factor, what's the solution. So now I have a factor, okay? So I know that this polynomial can be rewritten as f of x is equal to, what's the factor that I know? No, x plus 1 is the factor that I know, and then what's remaining? X squared minus 11x plus 28. Okay? So at this point, let me go down because I think the way I've done it in your book. At this step, we figured out that x equal 1 was the root, and x equal negative 1 is the root, and x plus 1 is the factor. So now, how do I factor x squared minus 11x plus 28? I need two numbers that do what? Yeah. Multiply to 28 and add to negative 11. Pardon me? That's what I'm trying to do right now. Okay, so what numbers multiply to 28 and add to negative 11? Yeah, negative 7 and negative 4. Okay, so this is x minus 7, x minus 4. So that means I should be good to my final answer now. My complete factorization is, what was the first factor? X plus 1? Yes. It's just a 1 in front of the x squared. You don't have to go through the grouping. You can, it's just an extra step. Because the number in front is a 1. Okay. If you were to do it, it would still work. Okay. So my final answer here is, this is what? x minus 4, x minus 7. So the only thing new today is this rational roots theorem. Synthetic division, you've done it. Factoring quadratic, you've done it. So now it's just that I'm giving you the problem and I'm not giving you the factor this given that this is a root or this is a solution. You're going to have to create a list of possibilities or suspects and then go from there. Now, this one's a little bit different. How is this one different? What degree is this guy? This is fourth degree, okay? If it's fourth degree, how many times do I need to get synthetic division to work? Twice before I get down to a quadratic, okay? So what are all the possibilities? So it's plus or minus the factors of what number? Yeah, the factors of 2 divided by the factors of 6, okay? So this is plus or minus, what, 1 and 2 over 1, 2, 3, 6. So this list is plus or minus 1, 2. Divide every number by 2, and you get 1/2 and 2/2. Divide every number by 3, you get 1/3 and 2/3. Divide every number by 6, and you get 1/6 and 2/6. What is 2/6? That's 1/3. So that's my list. This is why I like to simplify, because if I'm having to march down this list, I don't want to try 1/2 and then 2/4 and then 3/6. Those are all the same number. So that's why it helps to simplify that list. So what are you hoping works in this one? Or 2? Because you hoping you don't get to 1/2 and 1/3. Okay, so again, my goal is not to get you down to the end of the list and make you do everything. You should find success early on. So let's just start with 1. So let's just start with 1. And so here I have what? 6, 23, 28, 13, and 2. Okay, so I bring down the 6. What is 1 times 6? 6. What's 23 plus 6? 29. What's 1 times 29? 29. 29 plus 28 is 57. Now, before I keep going here, what are you noticing here? Do you think this is going to work? Why not? Well, yeah, this is positive. Every time I multiply, I get a positive. And then I add a positive number to a positive number. And then I multiply by a positive number, and I add that to a... Is there any way to multiply and add positive numbers all day long and get to 0? This is not going to work, okay? Yeah, so what does this mean? If any number works, it's going to have to be negative. So here's something you got to know. If all of your coefficients are positive, the only numbers are going to work are negative numbers, okay? So because of this, I see if I have all positive coefficients, the root must be negative, okay? Now this is just sort of going to save you time. So now I know I don't have to try positive 2, okay? So now I'm going to go to which number? I'm going to go to -1, okay? So let's go to -1 and see what happens. If the coefficients are all positive, there's no way a positive root is going to work, because you're going to be multiplying, adding all positive numbers. You'll never get to 0. So if something works, it's going to have to be negative. So bring down the 6. -1 times 6 is -6. That's 17. Multiply here, you get -17, and that gives you what? 11. Multiply here, you get -11. Add to get 2. I'm feeling good about this one. Okay. There we go. What does that mean? Yeah. So I now know that x plus 1 is a factor. Now here's the other question. I've got to find one more factor. Should I go back and try 1? No. If it didn't work before, it's not going to start working now, okay? So, pardon me? Well, because this is what? This is 6x what? This is my x cubed. That's my x squared. That's my x. That's my constant. I don't have it yet to a quadratic. I started out with a 4th degree, okay? So, I'm not going to go back and try 1 because 1 didn't work before and it's not going to start working now. Now, here's the question. Should I try -1 again? Yeah, it worked. It is possible that it works again. I don't know that. I haven't ruled it out. So once you rule a factor out, it is history. It is dead to you, okay? But because -1 worked, it might work again, okay? So I have to try that to see, okay? So let's try that. Let's try -1 again. So -1, but what is my starting point here? What numbers? Yes, 6, 17, 11, and 2. So bring this down. You get -6, that's 11. Multiply here, you get -11, 0. Multiply this, you get 0 and 2. So what did that really tell me? It does not work. Okay, so it does not work when I tried it the second time. Now what number do I go to? -2. And again, I could try +2. It's not going to work. No harm in trying it, but I know it's not going to work. So let's try with a -2. So -2. So 6, 17, 11, and 2. So -2 times 6, that's -12. That brings me a 5. -2 and 5 gives me a -10. That's 1. -2 and 1 gives me a -2. Ding, ding. What does that mean? Yeah, so I know what is the factor. X plus 2 is a factor. So now, where am I now in this problem? This is where people start to complain about how long these problems take. At this step, I know that what are my roots? I know that x equal -2 is the root, x plus 2 is a factor, -1 is a root, and x plus 1 is a factor. Okay. So what is the factorization now? I've got f of x equal, what are my two factors? Yeah, x plus 1, x plus 2, and then how do I read that piece of information right there? What is this? Yeah, 6x squared plus 5x plus 1. Now what must I do? You must factor the quadratic. So to do that, you need to find two numbers that do what? Yeah, multiply to 6 and add to 5. What numbers will do that? Yeah, 2 and 3. So that means I've got 6x squared. Pardon me? 6 and -1 multiply to give you -6. Okay. So 6x squared plus 2x plus 3x plus 1. Factor this by what method? Grouping. So that's 2x times 3x plus 1 plus 3x plus 1. What is that factorization right there? Yeah. Yeah, 2x plus 1, 3x plus 1. Well, so this final answer, after a lot of work, is f of x equal. No. That's the complete factor. That's as hard as these guys get, okay? That's a 4th degree. Yes. Right, you're trying to find all the factors. Because I started out with a 4th degree, I'm going to use synthetic division 2 times to get it down to a quadratic. Now you could keep with this quadratic. I could still keep guessing with synthetic division. But what is going to be the root? When I set this equal to 0, what's the root going to be? Negative 1/2. This one's negative 1/3. If you want to do synthetic division on this one, you're going to have to use fractions, okay? So I got rid of the ones that were integers to begin with. It's easier to factor a quadratic than to use synthetic division on a quadratic. So that's why we want to reduce it to a quadratic and then factor from there, okay? So this is where we're wrapping up here, and I've got one shortcut. You should be able to look at any polynomial and create the list of possible rational roots. You should be able to use synthetic division to reduce that polynomial to the factors you find in a quadratic. Now, what we just found out was, here's a shortcut. If all the coefficients are positive, don't waste your time looking for what? Positive roots. Only look for negative roots, okay? So if you don't catch that, all it is just a little bit of time and effort, okay? But if you have all positive coefficients, we just found out you're going to have negatives for your roots. Here's another shortcut. If all the coefficients add to 0, then 1 is a solution, or x minus 1 is a factor. Okay, so this one, it's one of those things, if you want to use that shortcut, it's helpful to let you know where to start. So if I look at this, what are the coefficients here? This is what? 1 plus 4 plus 1 minus 6. What does that add up to be? That adds up to be 0. If the coefficients add to 0, then it tells me I'm guaranteed that 1, so x equal 1 is a solution, and x minus 1 is a factor. So this just helps me shortcut here. So if you want to memorize it, that's a good shortcut. So I should be able to do what with synthetic division here? I should be able to put a 1 out here. I should do synthetic division. What, 1, 4, 1 minus 6, and this should work for me. So let's try that. 1 times 1, that gives me a 5. 1 times 5, that gives me 6. 1 times 6, this gives me 0. Now, what were the possible rational roots? It was what? Factors of 6 divided by factors of 1. I could still go through all of that process, but this is just a shortcut. There are only two shortcuts you're going to learn. If all the numbers are positive, only spend your time on negative roots. If the coefficients add to 0, you know to start with x equal 1. Okay, so what does this tell me this polynomial is? This is what? X equal 1 is a root, x minus 1 is a factor. So I'm left with what? X minus 1 times what? X squared plus 5x plus 6. And then how do I factor x squared plus 5x plus 6? Yeah, numbers that multiply to 6 and add to 5. What are those? Yeah, 3 and 2. So this final answer is x minus 1 and what? Yeah, x plus 3, x plus 2. That's the final answer. So how does this one feel? Okay. They're long, but they have rules that to follow. So what I'd like you to do, you guys work on this one, okay? So we've got a little bit of time before the end of class.
difficulty. Please pardon the interruption before the bell. We need the owner of a black Lexus GX, tag number RQB1795, to please come to the office. Again, the owner of a black Lexus GX SUV, tag number RQB1795, to please come to the front office right now.
I'm not the only person that drives it. Come on. I think it's on black Lexus GX.
Okay, how are you guys doing with this one? Okay, so go ahead and finish that guy up. So this one you had to get synthetic diversion to work twice, and then factor down to the quadratic. Okay, and I will see you guys on Monday.